Okay, so I want to go over um, how we've done the hierarchies before using the nest method for D3. Um, as time went on, D3 updated and nest was taken out. Now it's still available. It's part of the D3 collection package, whereas the new grouping functions, these are coming from the D3 array package. Now, in my previous talks, I had shown you how to do a hierarchy by creating a reactive grouping object, right, that used nest. And to be able to use something else, like the group method that D3 array has now, I just want to show you sort of a step-by-step on how to use that or nest, either or. Okay, so we're just going to break down this process. And we'll start very simple. So I've made, I wonder if we have it in here. Yeah. All right. So we have a data set of superheroes. All right. There's a lot. I don't know if they're all superheroes, but I cleaned this up, and inside this, actually, here, let's just make a table of superheroes. Slice. We'll just do the first like 20. Right. Okay. So this is what our data looks like. Okay, we have name, identity, alignment, eye color, hair color, blah, 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 blah. Now, most of these are categorical, which is good for us, so we can do grouping. And we'll use this as our pretty much our data source for using nest and using group and creating a hierarchy of that. So the first one we'll do is we'll do nest because that's what we've always done. And with nest, a nest, when you call the nest function, it creates an object for you. So we'll call it nester equals, and we'll do d3.nest. Okay. So nest gives you back this object that has entries, key, map, object, rollup, sort keys, and sort values. Now, these are kind of split up into, basically, I call them inputs and outputs. So you have the key method chains the accessor functions. The sort keys and sort values, they define the ordering of the values. And then output has object map and entries. Now these are functions that just return this nested group that you've created based on whatever data set you pass, right? But it comes back in different formats. So you can have it as a map, you can have it as a like an entry, key value entry array, or you can have it as an object in this case, right? So for all of these three things, it's the same data that you're getting back. It's just in a different format, right? So with group, and actually we'll create a grouped thing with our data. So we have our superheroes, and if we look at superheroes again, we've got a bunch of them actually. I think they're, no, maybe that's just it. Okay. So we could say we split it up by gender and then hair color and then eye color and then alignment, right? We could basically combine these any which way we want to do a multi-level grouping, okay? So we'll do identity and then status, right? So we'll see if they're like a secret person. I'm not sure exactly, to be honest. This is just a sample data set. I'm not sure if identity. We'll do alignment because that gives us a good idea of what that is, if they're good or bad or neutral or what, and see if they're still living or not. And then we'll add on the universe that they live in, right? Because there's basically Marvel or DC, and that makes sense too. So to do this, we created our nester object by calling d3.nest. The nester object contains these functions that we can use. So the first thing that we want to do is we want to start adding these keys. These keys represent the order in which you want to group your objects. So the first thing that we would do is we would say nester.key, and then we pass in an accessor function, which is basically, it's just a function that it expects a parameter to be of a single record in the data and to return a value that's based off of that record, right? So we can create these methods for or functions for getting a specific value back from every single record, right? And that's how we do this, is we pass in these methods. So we would say record, and then we want to get in the records what, right? Actually, I think I should put up, whoops. Let me just put it up here. We'll say superheroes.columns. String. Okay. That'll give us a good reference. So these are the different properties that we can get back from record, right? So we'll do record dot, was it alignment, I think? Yeah. Right, so that's whether they're good or bad or neutral, right? Or something else, maybe. And then we're gonna add, oh, I'm sorry. That's how we do with nest. Okay, so we add a single method for getting back the alignment, right? So once we do this, this nestor object has changed, right? When we call an initial set of data, we'll do this right now. Since we've added a single group, right? We can say nestor, and we'll just get back an object, right? And we're going to pass in our superheroes. So when we do this, we're going to get back an object that is now grouped by their value for their alignment, right? So we've got bad, good, neutral, and reformed criminals. And it looks like there's only one. Owen Mercer. I'm not sure who that is. But that's how we do it. Now, when we want to split it up again, see if we go into here, this is just a flat array of everything, right? But now we want to group it again. So we can say whether they are deceased or not, right? Is that what we did? Status, whether they're living or deceased. So we want to add another key, right? Nestor.key. And then we'd say record, and then we want to do record status, right? Now, if we call this again, we're going to get another level of grouping, right? So now we've got bad, deceased, living, right? Good, deceased, living, neutral, deceased, living. Oh, I guess this guy died. Okay. So you see how we have this pattern, right? So we'll add another one. We'll say nestor.key, and then instead of status, we'll do universe, right? I think that's what we're going to do. Right. So are they in DC or are they in Marvel? Okay. So if you think what would this would return, it would probably be right. It's going to give you back the top level, and then whether they're deceased or living, and which universe that they're in, right? So that's basically how you use nest to be able to do multi-level grouping. Now, to use hierarchy, in order to use hierarchy, we have a root object, okay? And that root object would have children. And then those children would have children, and those children, right? But it all starts with an object. Now we're getting back this object here, right? But it's set up in a way where there's really no pattern in knowing what the children would be, other than destructuring the object itself, right? Like getting the entries, for example, and getting back the value of whatever the entry is, whereas the key would be the child, I guess, right? Or the name of the child. So instead of doing it this way, you can use another method that the nestor object returns, which is entries. So when I pass in entries and I want to give my superheroes, right? This gives me the same data, right? That this is giving me, but in a different format, right? So I've got bad, good, neutral, reformed criminals. Here, neutral, good, bad, reformed criminals. And most likely it's in the same order, but when this prints out like objects itself, I believe it just makes it sorts them, right? So this is giving me the same data, but in a different format. And I can use this format because if you look at how every single one of these guys sets up themselves, we've got key and then values. Key, values, key, values, right? So we basically, all we have to do is just say, when we make a hierarchy, we pass in our root node, right? And in this case, this is an array, but we'll fix that. And then we pass in a method just like we did with creating those keys, right? Where it's like an accessor function. So we would pass in a method that says how to, like, what's the children of this node, right? As it's grouping things down and going each level down, there's a function that we can pass to it that says, well, return back what the children would be, right? So in this case, we make a function that says, well, it's going to be the node's values property, right? That's the children of every single one of these things that gets drilled down. So the only thing that's missing is this has to be from like a root source, right? And right now it's an array. So think about it, it's just a collection, and they're not children of any root parent. But all we got to do is make one, right? We can use this same pattern, this key values pair, right? So all we do is we just say my root data equals, we're just gonna make an object just like this is. We're gonna say key, we'll just call it root, values, and then it's gonna be the nestor.entries of our superheroes, like that, right? And this is our root data, and it's the same data that's coming from here, okay? So now that I have root data here, right, I can create a hierarchy from this. So I'll say my hierarchy is d3.hierarchy, and then we'll pass in our root data. And then for the children, you can see where I'm going with this. We'll say node.values, right? When we do this, we create, now we have a hierarchy. It knows that it has 4 levels. The actual data is assigned to every single node, right? And you have to think of it as this is the root node. These are the children nodes of this, right? And each one of these things has, an object that specifies what its parent is and everything like that. So we could basically travel down. You can find paths that go from one node to the other. There's a lot of useful functionality here, and you still have the original data that's available from whatever you passed it, right? So that's how we do it with nest, okay? If we want to do it with group, the way that we use group is sort of the same. We have a set of accessor functions, right, that need to be passed to it, plus some data, right? And this thing will group and then group and then group based on the order that we pass the functions to, right? The accessor functions to. So if we look at d3.group, it's looking for values. Whoops, sorry about that. Looking for values, right? Oh, what am I doing here? It's looking for values, and then it has these keys, right? This sort of extracted array of keys, right? These structured keys, okay? That basically just means that you could chain functions, function 1, comma, function 2, comma, function 3, right? So you do that in the same thing, right? So if we wanted to use group the same way, we just say group, we pass in our superheroes immediately, and then we start our function, so we want to pass to it. And I'm going to keep it short. I'm just going to do r dot alignment, comma, r dot status. I think we did status. r dot universe. Okay. So when we do this, we're getting back a grouped object again, right? But you can see that the format of it is completely different, and there is no object that we're creating like d3 group, and then we have this function that has entries, and key, all these things in there. You just, basically provide these values up front, and it'll create what's called an intern map, right? Which is similar to a map, used like map, but it just has some extra functionality to it. So D3 group returns this. If you wanted to do D3 groups, that basically returns the same data, but it does it as a key value entries pair of arrays. So if you look at that, you have neutral array, right? So you can see these are split up into different arrays. Okay. And then there's flat group, which is pretty cool. You can see what that will do. Okay. This gives us a flattened list of everything with the values of each key as a separate value in the index of the arrays, right? And then the last one is finally the array, the values that you have. So that could be useful for other things. So if you wanted to use hierarchy with group, what's nice about using group by default with hierarchy is that you have to imagine that an object that we're passing in, like we're passing in this key values. However, it's not necessarily iterable, right? But maps are, arrays are, and so if you just did, we'll just make another hierarchy. D3 hierarchy, we'll pass in, instead of root data, we don't have to create a surrounding root, right? All we have to do is just pass the group results. That's it. It's already a map and it's already iterable. So if we just do D3, actually, before I do that, let's make this an actual object, right? So we'll say group value equals, actually, let's say group map. Does that make sense? Group map equals that. And if I wanted to create a hierarchy out of group map, I don't have to do anything special with it. I just pass it in like that. I don't have to pass in a function here to specify what its children would be. I just do that. It gives me the same structure, right? Same children, nodes, everything. But the data is, obviously it's not it's an array of key value pairs, which the last one is an intern map, right? So an intern map, if you destructure just like you would with a map, you would have an array with a key and a value, right? So that's how you use it with group. You can use both technically. You can still use the collection package from D3 and still take advantage of Nest. I think Nest is it's convenient for some things. I'm sure that this is probably faster in some ways, but that's basically the main difference in grouping your objects using Nest and group. Okay. So now when we do view, when we want to have some sort of reactive environment to basically do automatic grouping based on a set of keys, we do this the same way we did it before. We just change this functionality instead, okay? And the way that we did it before is that you have an array of keys that you want to group by, okay? And this array is reactive. So when this array of strings change or added or removed or anything, this will recalculate a grouping object, okay? If we want to make something reactive, let's imagine we have a set of keys, right? So we'll just say sort keys equals, and we're gonna make this a ref. Actually, you know what? Excuse me. Instead of making refs, I'll just make it like just imagine that I'm making an object that you would like in a component when you make data. Okay. So I'll say sort options equals dev.composition.reactive, and it's going to be an object that's going to have sort keys, right? And we're just going to make it an empty array for now. And then what else? Trying to think of anything else I need to add to this. I'll just leave it like this for now and make it simple. Excuse me. Okay, so I have this sort options object. Sort options dot sort keys, right? Sort option dot sort keys is just an empty array, right? And then we'll say, we'll make a computed object, but it needs to be, we're going to use a ref, okay. So we'll say sorted or accessor methods. Here, we'll just do sorted accessors, okay? So imagine you have your set of keys that are, it's an array of strings, right? Which is easy to manipulate and stuff. You can take that and you can convert it to an array of accessors, right? Which are basically functions that they expect a record value passed to it, right? And it gets a value of that record. And the value of that record is the property of the string that we're iterating through. Okay, so in other terms, we'll say sorted accessors equals here, dev.composition.computed, right? We're going to make a computed ref. Okay, we're going to return back this set of sorted keys, right? Sort options. Right. We're going to say return array.from sorted options dot sort keys, right? Because sort keys is reactive. So if sort keys changes in any way, the sorted accessors computed value will update as well, right? So return array.from sort options dot sort keys, which is an array of strings, and we're going to get back instead of returning back a key, we want to return back a method that would get that key of some whatever record we want to get. Okay, so we would say return, and you could probably you don't have to like do these returns like this. I'm just kind of breaking it out, but you would say return array.from sort options dot sort keys, and for every key we want to return back a function that would be of a record, right? And we would want to return the record key value of whatever key that is being passed. Okay. So what this is going to do is it's going to, whoops, I need to add a little, like that. Right, yeah. Oops. Yeah. Okay. All right. So we have this sorted accessors done computed, okay? So now if we look at sorted accessors value, its value is just an empty array because we have no keys, okay? But if we wanted to add some keys, we could say, what do we call it? Sort options. Wait, sorted accessors. Oh, yeah, that's the sort options dot keys dot sort keys. Is that what I call it? Oh yeah, I did. Okay. Sort options dot sort keys equals, and then we're gonna say we'll do some different ones. We'll say gender, and then universe, and then appearances. Whoops, spelled that wrong. Okay, so we'll have this string, this array of strings, right? Now we've created this computed object called sorted accessors, and it's going to basically create, instead of an array of strings, an array of functions that would get that string of whatever record, okay? The property of that record. Okay, so now if I look at sorted accessors again, and I look at the value of it, now we've got functions, right? And each one of these functions just returns the value of its key, right? These are going to ask for a record. So if I looked at this first one here, you see it says record key, right? I would say that this function, if I passed in a superhero to this guy, right? Let's do like 3, the third one, right? I'm going to get back its gender. right? Because I'm using the first sorted accessor, which is the gender, and I'm going to get back the value of this guy's gender or girls or whatever, right? Okay, so we've created a reactive array of accessor functions. Now, nest and group both need to have this way of applying a sorted these keys, right? For nestor, we have this .key method that you have to pass in these functions, okay? And we have to do it in a specific order, right? And it will modify the nest so that when we pass the data to it, we will get a grouping based off of that, okay? So we'll make another, and actually, you know what? Instead of doing this, we'll do a watch thing, okay? We're gonna watch for these methods from when they change, okay? Now we can watch for the keys itself, or we can watch for these new sorted accessors, right? It's a ref, and we can watch this ref for when it changes. So we're gonna just make a watcher. I'll say watcher equals dev.composition.watch, right? I guess we could do the watch effect, but we'll do that later. We're gonna watch for the sorted accessors ref, okay? Now, a ref is basically just an object that has this value with other things in there, but you can pass in this just as itself. You don't have to pass in the value of this. You just pass sorted accessors. Whenever this changes, right, we want to basically create a sorted list, right? I guess we could do this many different ways, but we'll just do it a very simple way here, right? We'll say new accessors. I guess we don't technically need to do this, but that's the callback. All right. So we're gonna say new accessors. All right. So when we watch these sorted accessors, we're gonna want to create this nesting object with these new functions. Okay. Actually, you know what? I'm gonna scratch this. Let's do. No, I'm gonna keep this. Okay. All right. So if we did it in a watch, all right, we basically want to say for nest, we would say const nestor object equals e3.nest, right? And then we want to do this. With a nest object, we pass in, we call up the key function, and we pass in an accessor function into it in an order. And then after we do this, then we can pass in the data, getting it back as an object or whatever. So we basically just want to call a loop through all of the different accessors, right? We could do this different ways. We can say new accessors that for each, right? And it's the accessor function. We want to say nestor object dot nest. I'm sorry, dot key, and it's gonna. We just pass in the accessor function. Accessor function, right? Okay, so every time the sorted accessors change, we construct a new nestor object. We then loop through all of the different accessor functions that are available, right? And call this key method, right? And what this will do is it will transform our nestor object here to be able to now get value and return back to us this new group, right? Okay, so That composition I watch sorted accessors, new accessors, d3.nest, new accessors after each this. And then we want to say console.log, or you know what, let's make a new group. Const group val equals nestor object, nestor object dot objects. Actually, you know what, we'll get, it was the entries, right? I want to get back the entries, and it's going to be the data set, which is superheroes, like so, right? And let's just console log it, just to show group val, group val. All right, that should work. If it doesn't work, then I can call this watch now and then cancel it all. So let's try and do it. If we did sort options dot sort keys, it has gender, universe, and appearances. What if I wanted to say it equals just gender? Or yeah, just gender, right? What should happen is I should get a console log back of a grouping based on just gender. Okay? Male, female, blah, blah, blah. Right? All right, sort keys equals, let's just make a brand new one. Here, we'll do that. Here. Right. Now we immediately have our object split up like this. We can even do something like sort keys dot reverse. Right? Which will give us the reversed order, right? So in this case, now it's appearances, then universe, then gender, right? So however many appearances, that's why there's so many of them. Let's change appearances. Here, sort keys. Let's see if this works. Hold on. We'll say dev.composition.set. We're gonna set sort options dot sort keys. The key is gonna be 0, the first one, and we'll change it to be, instead of appearances, we'll make it universe. Let's see if this works. Oh, look, it does. So now I have universe and their, let's see, what was it? Sort options, that's sort keys. And let's put this up here too, because I want to, there. Right. So now if we change it to be, oh, universe and then universe. Okay. We'll say, let's set the sort keys 0 to be, instead of universe, let's make it here, let me just, okay. All right, so we have universe, universe, gender. Let's make the first one be identity. Right here, there we go. Identity, universe, gender, secret, PC. Right, so you can see that by watching or observing, making a reactive array of these keys that you're going to want to use, you can generate this new group. Okay, and in this case, we used the keys entries, and in order to do that, let's revisit that. In order to do that, we did this. We said we created a new nestor object. We then said for each of the accessor functions that we are observing, right, we are going to call the key method. After that's done, it's going to create the entry. It's going to call the entries function from this nestor object of by passing superheroes to give us the grouped value of them, right? We could do the same thing with, instead of entries, we can say object, like that, right? Because that's another method that's in there. I wonder if I did watch before. Oh, I might have to like restart this whole thing. Oh well. We might get here, let's do hair color. Set the person's hair color. I think I did call the like unobserved thing for the watch. Right, so now you can see that our new watcher, because we're returning back the object format of nest, we're gonna get back these now. Right? If I change here, I just want to make this like easier to access. Okay, so if I did the sort keys equals dot shuffle, or no, we'll do sample size. Right, so we're gonna sample just some random ones of these keys, right? The sort keys. I'm sorry, the columns, right? We can get superheroes.columns, right? This is all of these, right? And we're gonna get a sample of them. So out of those, we want to get, I don't know, 4 of them. Actually, you know what? We'll do another one. We'll say random amount between 2 and 8, right? And let's make sure that it's an integer. Sample size. Okay. It should work. Let's see if it happens. Oh, I think it needs to be a ref to it. All right. Sorry. We'll just do this. We'll just say sort options dot sort keys equals sk, right? That we just made. And we'll just do this. I don't know why. Sort options dot sort keys. All right. So if we do this, we're gonna just keep randomly getting these groupings, right? So this is by identity, and then eye color, and then hair color, and then it's universe, and then what is it? And then appearances, and then gender. That's a lot, right? So this guy had 14 appearances. Right, blue identity unknown. No new authorities. Right, we'll do it again. We can call it again and get a completely different one. You see? We could put this in some loop. We'll say right, we'll just put this in some constant loop, and every second and a half it will it'll just give us a new random grouping. There's a random group, another random group, another random group, another random group. All right, there. Okay. So we did all of that with nest. All right, let's do it with groups, and it's the same thing really, but we just pass in. It makes it a little bit simpler, right? So instead of doing nested objects is this and that, all we have to do is say const group val equals d3.group, right? And it expects the data set to be passed to it, and then the keys. Now the keys are it's the accessor functions that we're watching actually, right? These new accessors. So instead of doing all this other extra stuff, we just pass in new accessors, right? That's all we have to do, right? Those are the new functions that are going to create a group. Okay, so now if we do this, let's try it again. We'll say, you see? Now we're using the grouping method now, right? I could do the same thing and say, let me call watch again. All right, instead of doing group, we could do flat group. We could do flat roll. I mean, we can do whatever we want. The point is that we observe an array of keys, and based off of the order of those arrays, whenever they change, we construct a new set of groupings, right? That we can then pass to create a hierarchy. We could even combine hierarchy and create it in here, and then do some other things with it. You just have to keep in mind that when you're making things reactive like this, you need to be careful about how much you're observing things, right? And how many things are needed to be recalculated. Okay, so for example, if we make a hierarchy and we want to visualize this hierarchy, and we put it inside of a circle pack, right? If the hierarchy itself changes, right? We would basically want to recall the layout onto it. We would want to summarize and count based off of like the new data that's coming in, right? But let's say we want to just change like the padding of this layout, right? Changing that will require this to go through the hierarchy again and recalculate its positioning, which is it has to do this. But by changing that value, the hierarchy itself never needs to be recreated from the group, right? The hierarchy should never change unless this grouping thing that like we're doing here would come back as something else, right? Let's do this interval thing. Loop equals set interval. Okay, right? So if we did, kind of stinks that I can't really see any of it. But I forgot where I was even at. Let's clear that interval. That's kind of annoying. All right. All right, so that's really the only thing that changes is this way of converting these sorted keys into a grouping method, okay? I mean, you still have this array of accessors that you can pass, but with nests, you just do it a little differently. You have you loop and call a function over and over. With something like this with group, you could just pass in the values as a deconstructed array. Okay. And that's basically how you set up reactive grouping. Oh, that's the other thing I wanted to say. So when you're constructing the layout, when the grouping changes, you need to create a new hierarchy, and creating a new hierarchy, it will basically take your groupings and iterate over them again. But then it has to do a couple other things. After it does this, it has to count, right? So after it does its grouping, it then goes in reverse order back up and counts the amount of children are within each node, and then so on and so forth, right? So you have the leaves. The leaves are the actual records that you have passed, okay? Or I should say they're the nodes, they're the last nodes. They don't have any more children, okay? And then those are leaves. Everything else are they're branches, right? Branches have children. They extend, okay? So when you create a hierarchy, it iterates from the bottom up and counts all these children and gives the parents of those children the amount, right? And then it basically does this over and over and over. And it adds and adds and adds. So the very root node will have a value of basically all of the nodes that are available, right? That's the count, okay? And these layouts they need to use a some sort of value that a node has, right? And by doing this on a hierarchy, just by doing count, which is sort of the default, because as long as you have nodes, you can count them. But if they have other values, for example, you can summarize on those. The point is you have to iterate through this hierarchy again in order to combine all of these summaries, right? So that you can construct a layout whenever you need to. So if I change the padding on a layout, I might have to calculate the positioning of everything, but I don't have to re-summarize a hierarchy or resort it or do any of that, right? That should only happen whenever the data set changes, right? Or if the sort keys has changed, okay? But aside from that, then, applying a layout, it only needs to do that. And yes, it will have to iterate, but it doesn't need to do all these, the other extra, more expensive computations, okay? Now, you can apply this to a view component, and right now we're just doing it in the console, but you can see that you're able to make it reactive, okay? You can apply the same approach to making a hierarchy, and based on what I had mentioned about having things that will summarize or count, you got to make sure, just be careful and separate that out. If you combine all that stuff into one computed object or one watcher, it's going to look and say, oh, your padding was changed or whatever was changed. Let's recalculate everything again. We don't want to do that. So it's good to separate this out. And like I said, there's many other ways of doing this. This is just one example of doing it. But yeah, so that's it. I'm going to edit this video now. Take care.